Today we're going to be talking about 7.6, Solving Inequalities. The first word we have here is what an inequality is. It's a mathematical sentence formed by placing an inequality symbol between two expressions. Now, while you might think I have no idea what an inequality symbol is, we'll talk about them here in just a minute, but it basically is something that's greater than or less than, okay? So you put that instead of an equal sign. Then, a solution is a value that makes a statement true. So let's imagine that I have x plus 2 equals 5. Does anybody know what the solution to x is? What should I put there instead of that x? A 3, okay? So this is just saying 3 would be the solution for that. So a solution is a value that makes a statement true. First step says, tell whether the value of m is a solution to the inequality m is less than or equal to 3. So what we're going to do is we're going to start with that inequality that it gave to us. And we are trying to figure out if this statement would be true about a number 1. So the first thing you're going to do is write down the original problem or the original inequality that it gave to us. All I'm going to do at this point is take this number and plug it in to where that m is. So instead of saying m is less than or equal to 3, what will I put there? 1. 1 is less than or equal to 3. This is kind of like that plug it in that we did at the beginning of the year. You're just plugging in a number. So now the question has asked, tell whether or not m is a solution. Is this true? Is 1 less than or equal to 3? Yes, it's less than 3. 1 is less than 3. So yes, this is a true statement and 1 is a solution to that inequality. Basically what that symbol right here is saying is 1 is less than or equal to 3. Yes, 1 is less than. Let's imagine that it had said 3 is less than or equal to 3. Would that be truthful?
Yes.
Yes. Why?
Because it's equal.
Because it's equal to it. So this right here is basically another way for putting an equal sign. That says 3 is equal to 3. That's what that little symbol means. Let's go ahead and go over here to problem B. We're going to start with our original inequality, which says m is less than or equal to 3. Stephen, what will I plug in instead?
12 is less than 3.
Less than or equal to 3.
Which is no.
Okay, that's not true.
Wait, what is? Oh.
Because no, 12 is not less than 3, and 12 does not equal 3. So no, that's not a solution to this inequality. These are some symbols you're going to have to know and understand whenever you're graphing an inequality. The first one is what kind of a symbol?
Greater than.
Greater than, okay? So as you're reading it, remember everything's going to be read from left to right. 8 is greater than 7, okay? This one would be read, 7 is less than 8. All right, so that's how you read those. Now, the only difference here is this one has one little line there. What does that little line mean?
Equal to.
Equal to. So you're thinking it looks like an equal to sign, okay? So let's imagine that I have 7 is greater than or equal to 7. Is that true?
Yes.
True.
Yes, it is. Why?
Because 7 line under it.
Because 7 does equal 7. Would this be true? 7 is greater than or equal to 6.
No.
Why not?
Because.
Yes, that is true because 7 is greater than 6. Next option down here. This says, let's say 5 is less than or equal to 10. Is that truthful?
True.
Yes, because 5 is what? Less than 10. It does not have to be equal to and less than. That's not even a possibility. So 5 is less than 10, so that would be correct. Next thing I want you to look at, if you look at this right here, what two symbols are those?
Greater than, less than.
Greater than and less than. Anytime you have a symbol that says greater than or less than, you can see right here, it's going to be a circle that's open with nothing shaded in the middle. Now, what is the difference between this and these? Maddox. The two lines that are underneath it. Connor, what do those lines mean?
Greater than or equal to, less than or equal to.
Okay, When it has that equal to part on it, you can see right here you are going to have a closed circle where you are shading things in. Write an inequality represented by a graph. In this case, it did not tell us what variable to use, and anytime it doesn't tell you what variable to use, we're just going to put an x, okay? So the first thing I want you to do is stick an x right here to the right of this inequality graph. Now I want you to look and see, do I have a closed circle or an open circle? It's an open circle because it's not shaded in, okay? So that means that this -3 right here cannot be a solution to this graph. But we can see that the circle landed on the -3, so that is going to be what I put right here. Now the only thing that I need in between those is I need to put some kind of an inequality symbol right here. Since that's an open circle, I want you to look at your notes that we just wrote. What two symbols could I put in that area right there? I could put greater than or less than. So now I'm just trying to figure out, you can see right here that all of these solutions have been shaded in. That means all of those going in this direction here are a solution. So if I take, let's say the number 1, and I stick it right here, and instead of an x, I had a 1. Would you say 1 is greater than -3 or 1 is less than -3?
Greater.
Okay, you say greater than. So let's just check this out. We're going to say and assume we think it's going to be greater than. Let's choose another number that was once again right here on the original graph that it gave to us. Let's just try a 0. If I were to plug in a 0 right here, is this true? 0 is greater than -3.
Yes.
Yes, it is. Very good job. So the answer here to your inequality is x is greater than -3. Now I want you to imagine, this is the kind of graph that could just keep going and going and going and going. What's a large number that could still be on that graph if it kept going to the right? 10?
20.
A million? 20? That's true. So let's just check to see if those are truthful. 10 is greater than -3. Yes or no? Yes. A million is greater than -3. Yes. So excellent job. You just figured out how to write an inequality. Let's do another one. Every time that it doesn't tell us what variable to write, we're going to use x. So let's go ahead and put an x. CJ, what number did my circle land on?
Number 2.
Not just a 2.
Oh, -2.
-2. So I'm going to write -2 here. Now once again, I have to figure out if this is an open circle or a closed circle. What kind is it?
It's an open circle.
Open circle. So looking at your notes, what are my two options, guys?
Less than and greater than.
Greater than and less than. So it's either going to be this or this. Let's just see. Now you can see all of my solutions are going in what? A positive or a negative direction? Negative direction. So let's choose one of those numbers that it has shaded over. Marcus, what's one number that is shaded over on my graph? Not just 5, but which one? All right, we'll try a -7. He wants to do the very last one. So let's just try to plug this in right here. Now, sometimes when we have negative numbers, people get tricked up. So think about it like money. Let's imagine that I have -7 is this truthful? -7 is greater than -2.
I don't want to be in debt $7.
No, if I owed somebody money, I do not want to owe them $7. I'd rather owe them 2. So let's see then if this makes sense. Think of it like dollars. -7 is less than -2. Yes, that is truthful. So I'm going to go ahead and stick it here and assume that's probably right, but I want to go ahead and just double check with one other number that is shaded in here. What's another number that's shaded in there? -6. You chose one pretty close, so let's just check it out. Could I have put right here -$6 is less than -$2? Yes, that is truthful, okay? So this is my inequality. Who can give me an inequality if I had continued to go this direction that could have also proven to be truthful? Micah.
8.
Okay, a -8 could have worked, and that would also be truthful. -8 is less than -2. So let's go ahead and go to the next one. First things first, Darcy, what's my variable? Variable is a letter? X. I'm going to use an X. And what number did you say we had there? 2. Pearson, what kind of a circle do I have? A filled-in circle or a closed circle, okay? So anytime I have that closed circle there, what are my 2 options, class? Greater than or equal to, or less than or equal to. So now I've got to figure out what can go in the blank right here. Let's start with this one right here, a 4. If I was to put a 4 here, you would say 4 is what then 2? All right, you would say that it was greater than or equal to 2. Let's try another one. Notice that 2 is shaded in. If I were to plug in that, could I say 2 is greater than or equal to 2?
Yes.
Yes, why?
Because it's equal to.
Because 2 equals 2. So that helps me to know and understand this is correct. Now, this says all solutions are greater than or equal to 2. So while this thing right here could continue going on and on and on and on forever, you could come up with all the way over to the number 100. And if I were to plug in a 100 right here, would this be truthful? 100 is greater than or equal to 2. Yes, because it's greater than 2, all right? So all this is saying is all solutions are greater than or equal to 2. Now we're going to basically be doing the opposite. Beforehand, it gave us the graph. Now we are going to come up with the graph. So read me what problem A says.
X is less than 2.
X is less than 2. Let me have everybody read that with me.
X is less than 2.
So the first thing you're going to do is you're going to write a number line. To make things slightly more simple for you guys, I'm not going to make you put 1,000 different numbers on this number line. I am going to have you put 3 numbers on your number line. That's all I require of you. The first number, to make it real simple, is going to be whatever was there in the original problem. What number was there? 2. So that 2 is going to go right in the middle of your number line. Now think about a normal number line. It goes from smallest to biggest. What is 1 less than 2?
1.
What is 1 more than 2?
3.
So you can read right here, 1, 2, 3. You're making a simple little number line with only 3 numbers. Now, we've got to discover by looking at my inequality symbol, is this a closed circle or an open circle?
Open.
Why is it open?
Because there's no negative numbers.
Because there's no equal sign. If there is no equal sign, you have an open circle. Now, I have to figure out which one of these numbers would be truthful. So let's just start with the left side. 1. Could I put a 1 here?
Yes.
1 is less than 2. Yes, I could. So I want to shade over that 1. You have shaded over saying 1 is a solution that I could put there. Let's just imagine that my number line continued going on. This next number would have been a 0. Could I stick this here? 0 is less than 2.
Yes.
Yes, I could have, because 0 is less than 2. Let's imagine instead that I was going this direction. Could I have put 3 is less than 2?
No.
No. Why?
Because it's greater than 2.
Because it's greater than 2. So I don't want to shade in this direction because 3 is not a solution. That's why I shaded to the left. Now, I want to teach you a little trick. Do you see the direction that the arrow is going like this? Do you see what symbol that looks like? It looks exactly like that symbol. So there's a little trick. Your arrow should look exactly like your inequality symbol.
Man, I didn't want you to say that.
Problem B. We're going to go ahead and start with a number line. How many points will I put on my number line?
3.
You only need to label 3 points. Connor, which one goes in the middle?
-2.
-2. Now, don't get tricked up by negative numbers, but what number is less than -2?
-3.
-3. What number is greater than -2?
1.
-1. Now, help me out, please, Jaden. Is this going to be an open circle or a closed circle? Why is it a closed circle? Because there's an equal sign. So what that is saying is this right here. Negative 2 is a solution, okay? I can stick this negative 2 right up here, and I will know negative 2 is greater than or equal to negative 2 because negative 2 does equal negative 2. Now I've got to figure out which other one can put up there. Is this true? Think about it like money because it's easier to think about negative numbers like money. Negative $3 is greater than or equal to negative $2. Yes. Is that true?
Yes.
Negative $3 is greater than negative 2.
No.
No, I would not want negative $3. Let's try the other side. Negative $1 is greater than negative $2.
Yes.
That is true. So that means I want my arrow to be covering up the negative 1. Now, if you have a hard time with negative numbers, I want you to think about, as I go in this direction, what would have been the next number?
0.
0 would have come next, and then what?
1.
1. So get yourself to a positive number, and let's plug this in. Could I put in here? 1 is greater than negative 2. Yes, you could. So we know anything that is going to the right over there is going to be a correct answer, which is why this right here says all solutions are greater than or equal to negative 2. These are some rules that we talked about last week. First rule, identify the variable. Next up, you have to move the number that's keeping the variable from being alone with an inverse operation. What does inverse mean?
Opposite.
Opposite. So we've talked about our opposite or our inverse operations. What's the opposite of addition?
Subtraction.
What's the opposite of multiplication?
Division.
And one final reminder of what we talked about, number 3. What does it say?
What do you do to one side, you must do the other.
We always got to be fair, okay? So how many of you remember us talking a lot about that in our previous couple chapters? All right? Hands down. Go ahead and have a seat. Write this down. We're going to use those instructions and those rules for these final 2 problems today. First up, we have to solve the inequality. This is going to be just like the one-step equations that we were doing before. The only difference is this time we have an inequality symbol there instead of an equal symbol. But still, I want you to imagine this as if you are splitting it. This is one side and this is the other. What is not allowing the variable to be alone?
D. Negative 2.
Negative 2, because remember, every number has a sign, and that sign is directly in front of that number. Negative 2 or minus 2 is not allowing D to be alone. What is the inverse operation that would let me get rid of negative 2? Add by 2. So now on the left side, I'm going to add by 2. Remember the rule, what you do to one side, you've got to be fair and do it to the other side. So now, once again, you're still thinking this is the side that's to the left of the inequality symbol, and that's to the right. So what happens to my negative 2 and positive 2?
They cancel out.
And I'm left with
D.
D. Now, you normally would drop down an equal sign. Now I'm just dropping down less than or equal to, because that's what that symbol is. Now over here, what's 1 plus 2? 3. So now you've got a problem very similar to what we just had on the last screen. Now I have to graph my inequality. How many points will be on my line? 3. Hannah, what number will go in the middle? 3, okay, because you always put whatever that number is right there in the middle. Guys, what's 1 less than 3?
2.
And 1 more?
4.
4. Help me out. Deasia, is this an open circle or a closed circle? Okay, why is it a closed circle? Because there's an equal to sign. So basically what this is saying is, since it's a closed circle, I could take this and put it right there. Is this truthful? 3 is less than or equal to 3?
Yes.
Yes, because it equals 3. Now I have to figure out which direction my arrows should be going. So let's start with the left side. Could I stick this in here? 2 is less than or equal to 3?
Yes.
Yes, because it's less than, okay? So that shows me I need to go ahead and shade over. Now, who can give me a number if I was to continue going on and on and on forever? What's one of those numbers that would be over there on the left side?
Negative 30.
He says negative 30. All right, if I kept going, yes, I would eventually hit a negative 30. So let's see if we could plug that in. Negative 30 is less than or equal to 3.
Yes.
Yes, so that helps me to know I did do it correct. Then another way to check it is, see how my arrow looks this way? Notice how my arrow looks the same way right there. They are both facing the same direction. So those are some ways you can double check to see if you did it correctly or not. You could also see if I tried to plug this one in, because notice I did not shade over this way saying that that was a solution. So let's see, if I plug this in, is this truthful? No. 4 is less than or equal to 3?
No, that's
not correct. So I know I did it correctly. I want you guys to go ahead and go on to problem B and try to do it on your own. What is not allowing -6 or the x to be alone? -6. What's the inverse operation? Add 6 to both sides. What am I left with on the left side?
X.
Just an x is what? Greater than
18.
Okay, now all you're doing is 12 plus 6, which is 18. Please box that in because that is the inequality. Now, you're going to go ahead and make your number line. How many points do I want on it?
3.
All right, you're allowed to do more if you wanted to, if that helps you, but I only need you to do 3. What should my number line number in the middle should be in?
18.
What goes to the left? 17 is less than 18, then 19. Gavin, is this an open circle or a closed circle?
Open.
Why is it an open circle?
Because the greater than he doesn't have a line over.
Okay, there's no equal sign, which means 18 cannot go here into this. I cannot say 18 is greater than 18. That doesn't make sense. So it's an open circle saying that's not one of my solutions. Now, let's just start plugging things in. Start with the 17. Can I put this here? 17 is greater than 18.
No.
Nope. Let's try over here. 19 is greater than 18. Yes. So that means I should shade over this one. Tell me a number that would still continue to be in this direction going that way.
1 unitillion.
Okay, that's a very big, we're just going to say 1,000,000. Is it true? 1,000,000 is greater than 18.
Yes.
Yes. Therefore, you know you did it correctly. Next one. Check the arrows. That looks like a greater than symbol, and this is a greater than symbol. So you can tell you did do it correctly. Tonight's homework is not like a normal homework assignment. It is a flipped classroom, so you want to go onto my YouTube channel and look for 7.5, and then you are going to take notes on the piece of paper that I handed to you at the beginning of class, okay? So tonight's homework is not doing anything except for watching the video and then taking notes from the video.
Hi, Mom. This is Carson. I know I play Fortnite a lot, and I know that my hairline's curvier than a banana. But I love you, and I know you love me back, but that's all. Bye. Bye, Mom. Love you. Give me Cheez-Its.
Sorry, we got interrupted. The end.